Hey everyone, welcome to Homeschool. Hope everybody are doing good. And today I have come up with the most awaiting video which was requested by many students. That is solving model question paper which is previously released by Karnataka board. Right? So here is a model question paper, science model question paper solving session for SSLC 2023 examination. Okay, see, the model question paper pattern is exactly similar to 2022 exam pattern itself. Okay, in the pattern there is no difference, but difficulty level may increase. Okay, so 20% of the question paper will definitely on application based questions. Okay, so you have to be very careful. You have to be perfect with every concept of the chapter. Only then you can think of attempting these indirect questions or twisted questions or application questions. Okay, so quickly let us go into this model paper. See, the model paper has the three parts: part A, part B and part C. So the entire paper is divided into three parts. Part A is completely on physics chapters. Okay, so part A contains physics questions. Part B questions are on chemistry part, and part C is on biology chapters. Okay, and part A has got a weightage of around 28 marks and part B has 25 marks weightage, and part C, biology chapters, has a weightage of around 27 marks. So altogether you are attempting the examination for 80 marks. Okay, so this is the overall pattern of question paper. So now I am dealing with part A physics questions here. So in every part you have MCQs, 1 markers, 2 markers, 3 markers, 4 markers, and in any one part you will observe 5 marker question also. Okay, so all these questions, so let us try to solve it, and I'll also give an awareness about the concept involved behind these questions, so that to some extent the concepts also gets revised. Okay, fine. Coming to question number 1 of part A. Okay, so first main question number 1. So you have 3 multiple choice questions here. So you can just look at the question on a board, and the PDF link of this question paper is provided in the description. You can go and check it out. Clear? So look at the first question. The device used to change the resistance at many times in the electric circuit. Options are given: electric generator, electric motor, galvanometer, rheostat. Definitely rheostat is the answer, right? So that is option D, rheostat. So rheostat is the instrument that is helpful in measuring variable resistance. Whereas if you talk about the first option, electric generator. So electric generator is a device that is used to convert mechanical energy into electrical energy. And electric motor, opposite, converts electrical energy into mechanical energy. And galvanometer is used to measure electric current. Okay, so it is used to detect whether electric current is induced or not, right? And you have some more devices like ammeter, right? So all the devices uses you must know, guys. So according to my knowledge and experience, I can say this, that is one question either in the form of MCQ or for 1 mark, you will get one question based on these devices. Okay, so one question definitely on the devices. So what are the devices you will observe in various chapters? Say the first one is rheostat, which is used to measure variable resistance, and the second one is ammeter, right? So ammeter is used to measure electric current, is used to measure electric current. And next, voltmeter, right? So voltmeter is used to measure voltage. Then like in one of the option you have galvanometer, right? So this galvanometer is used to detect current. So whether electric current is induced or not can be detected by this galvanometer. So used to detect current, right? And then you have generator. Generator is used to convert what? Mechanical energy into electrical energy. Electric motor is opposite. It is used to convert electrical energy into mechanical energy, isn't it? See, these instruments are very, very important. Not only that, their units are also very, very important. Okay, so units in the sense electric current. So unit of electric current, unit of resistance, right? Units of resistivity, unit of voltage. Okay, so their units are also very, very important. Okay, so this is one of the essential concept on which you should have an idea about. Fine, that is all about our question number 1. And coming to question number 2, the same multiple choice questions. Question number 2. The correct statement among the following related to concave lens. So they have given 4 options like concave lens converges the light rays, forms inverted image, forms real image, diverges the light rays. So concave lens actually diverges the light rays, right? So here option D is the correct answer, right? So concave lens, this is our concave lens. So whenever this center of the lens is called as optic center, right? So this is a principal axis, right? So whenever a light ray falls on a concave lens, so the light ray will diverge, isn't it? Refraction takes place. In case of lenses, the refraction of light takes place and all the light rays that hit here will get diverged. Okay, so converging in the sense what? All the light rays meeting at one point, that actually takes place in convex lens. Okay, but here in case of concave lens, the divergence of light rays takes place, right? So this is very, very important. In case of mirrors, right? So you have 2 mirrors here, concave mirror and convex mirror. Concave mirror and convex lens will behave one way. In both of them, the light rays will get converged, whereas convex mirror and concave lens will behave in one way, right? So in both of them, the light rays will get diverged. Okay, so here the light rays are converged at a particular point, that is at focal length, whereas principal focus. Okay, and here the light rays will get diverged. Okay, so they won't converge, they move away, right? So this is one important idea you should always have about. Fine. Coming to question number 3 here. The resistivity of 4 materials are given. So I am talking about question number 3, that is third MCQ. So there are 4 materials A, B, C and D. Okay, so they have given resistivity values here. So the resistivity value of A is 6.84 into 10 power minus 8 ohm meter. So ohm meter is the unit of resistivity, right? And material B has got a resistivity of around 1.62 into 10 power minus 8 ohm meter. Whereas material C has got resistivity of around 5.20 into 10 power minus 8 ohm meter. and material 4, that is material D, has got resistivity 2.63 into 10 power minus 8. Okay, and what they are asking you is which of these materials has very less electric conductivity. Okay, so you have to select the one which has least electric conductivity. So what is the relationship between resistivity and conductance? See here, resistivity rho, this is the symbol for resistivity, right? So resistivity is inversely proportional to conductivity, isn't it? So the material which has got a high resistivity is a poor conductor of electricity. Okay, so usually the conductors have the least resistance or the least resistivity, right? So resistivity and conductivity are inversely proportional. So what they are asking you is you have to select the one which has got least conductivity. Least conductivity means high resistivity. So which of them is higher value here? That is what you have to select. See, all are like 10 power minus 8, 10 power minus 8. So here you check it out. So which is the highest value? Definitely the highest value is 6.84. So material A has got least conductivity. Okay. So material A is mentioned in option C, right? So the correct answer for third question is option C. Okay, so material A, since it has got highest resistivity value, it will show least electric conductivity. Okay, so this is our concept. Do not ever forget this concept. You know, as far as my experience, and this is a very common model from the chapter electricity. Okay, so they may give you the resistivity values and they'll ask you to select the one which has got more conductivity or less conductivity. So be careful with this concept. And coming to second main, so multiple choice questions are over. So now we are coming to the second main, that is 1 marker questions. See, question number 4, they asked you to draw a circuit diagram here. It's very simple. Draw the symbol diagram of 2 electric cells that are connected in series in an electric circuit. So here actually you have to draw the diagram on resistors in series. Okay, so how do you connect the resistors in series? See here, this is our battery, right? Negative terminal, and this is positive terminal. So somewhere here is a plug key. Okay, and here you will have ammeter and 2 resistors I will connect in a series. So this is R1 and this is R2. So show the direction of current. So current direction is always from positive to negative, right? So this is the direction of current. So this is the circuit diagram you can draw. And fifth question, what is optic center of spherical lens? It's very simple. Spherical lens, you have 2 spherical lens, right? One is a convex lens, the other one is concave lens, and the center of the lens is called as, center point of a lens is called as optic center. Okay, so what is the definition you will write? Central point of a lens is called as optic center. So that is the answer for 5th question. So with this we are done with 1 marker questions. Now let us go for 2 marker questions. Third main has got 3 questions, 6th, 7th, 8th. Each question carries 2 marks. And here is our 6th question. What is solenoid? List the properties of the magnetic field due to the flow of electric current in a solenoid. See, first thing, you have to write the definition of a solenoid. See, a coil of many circular turns, right? So I am writing a definition in a simple way. A coil of many circular, okay, turns of insulated copper wire is called solenoid, right? So you all must have seen a diagram. So this is a insulated copper wire which was in a shape of a cylinder, okay, which has got many circular turns. This is what we call as a solenoid. And they have also asked the properties of magnetic field in a solenoid. So you can write point wise. So the first major point is magnetic field lines, MF in the sense magnetic field. Magnetic field lines are parallel inside a solenoid, right? So usually solenoid act as a bar magnet. So solenoid will behave as a bar magnet. So inside a solenoid, magnetic field lines run parallel. They travel in a straight line, right? And magnetic field strength is same in all points. Magnetic field strength is same in all points, right? Inside a solenoid. This is one thing you can write. And the third point is, strength of magnetic field. Strength of magnetic field is directly proportional to turns, circular turns, right? Circular turns. More the turns you have, more will be the strength of magnetic field. And it is directly proportional to strength of electric current also. Directly proportional to electric current also, right? So any 2 points, whichever the points you feel easy, any 2 points you can write as a answer. Since it is a 2-mark question, definition of solenoid is enough, and among the many properties, any 2 major properties you can mention. So that is all about our 6th question. And coming to 7th question, very simple question from human eye chapter. How does rainbow form in nature? Explain. See guys, here is the answer that I wrote it in a simple words for you. See, I wrote 3 points. You can present your answer as it is. So let me explain you point wise. Point number 1. It is caused by dispersion of sunlight by tiny water droplets in atmosphere. Very, very important. Dispersion in the sense separation of colors, right? So water droplets are acting as tiny prisms here. Look at the second point. These droplets act as small prisms. So what actually happens inside a droplet is, suppose if you take this as a water droplet. So this is our water droplet in the atmosphere, which is acting like a prism. So in prism, separation of colors takes place. That is, dispersion of sunlight takes place, isn't it? Say, suppose if this is a sunlight, okay, so this is a beam of sunlight falling on a droplet. So what happens is certain level of refraction takes place, bending of light takes place, and the separation of colors takes place. Colors are also separated, okay, so red, violet, blue, indigo, all the colors are getting separated. And now all these colors will reflect, okay, so this is refraction. See, in the first step, refraction is taking place. Refraction, bending of light is taking place whenever a light is hit on a surface of a droplet, right? Change in the medium, so speed of light changes, so bending of light takes place. So in the first step, one level of refraction takes place. Later, inside a droplet, all these light, dispersed light is there, no, that will reflect. So this is reflection. And after reflection, again this light is getting, it is coming out from a droplet. So when it is coming out from a droplet, again certain level of refraction takes place. So this is a second step of refraction. Okay, so the dispersed light will refract, isn't it? And these are the different colors, and these colors actually reach our eye. It will appear as a rainbow, okay? And here internally, within a droplet, the light is getting reflected. This is called as internal reflection, okay? So this is called internal reflection, okay? So what is happening here? Sunlight, when incident on a droplet, refraction taking place, later internal reflection, then that reflected one is again getting refracted outside. Okay, it is coming out and the dispersion of light also is taking place. So the different colors will appear to our human eye. Okay, so that is how rainbow is caused. Right, so these points only I have listed on a board. So first point is very clear, it is caused by dispersion of sunlight by tiny water droplets in atmosphere. Each and every droplet will act as a small prism. And look at this point, they refract, see first level of refraction and disperse. After refraction, dispersion, separation of colors is taking place and all these colors will reflect in the opposite direction. Okay, after reflection all these colors will get refracted. Okay, they will get refracted and the colors will appear to our eye. So that is what the meaning of this sentence. They refract and disperse the incident light rays, then reflect it internally, internal refraction happens, and finally refract again. Due to this, different colors reach the eye. Okay, so this should be your answer in a proper way. Clear? That is all about the 7th question. Now coming to 8th question. Coming to 8th question, ray of light traveling in air enters obliquely into water. So this is a medium air and here you have water. And you should know air is a rarer medium, lighter medium, and whereas water is denser medium, right? Fine. And a ray is entering obliquely, it is hitting obliquely. This is incident ray and this is our normal. Okay, so this is normal. What they are asking is, does the light ray bend towards the normal or away from the normal? So always whenever a light ray is traveling from rarer medium to denser medium, the refracted ray will be passed towards the normal. Okay, so rarer to denser, the light ray will get reflected towards a normal. Whereas if it is taking place in an opposite way, suppose if the ray is entering from a denser medium to rarer medium, then obviously the refracted ray will go away from the normal. Okay, so here now it travels towards the normal. So you have to write it travels towards the normal. Refracted ray is towards the normal. And why they are asking? This is because the speed of light decreases, isn't it? So whenever the light is traveling from rarer to denser, the speed decreases. If speed of light decreases, what will happen? It will move towards the normal. If the speed of light increases in the second medium, on traveling into second medium, if the speed increases, then the light ray will move away from the normal. If the speed decreases in the second medium, it moves towards the normal. Okay, so this is what your answer. So your answer is very simple. The refracted ray moves towards the normal. Reason they are asking, reason is the speed of light decreases in a denser medium. In rarer medium, speed is more. Okay, so that is all about the 8th question. Coming to, there is an option. There is a OR question for 8th question. Okay, so this is also very simple. Convex mirror is commonly used as a rear view mirror in vehicles, and why? Okay, it's very simple because they form erect and diminished image. Okay, so they form erect and diminished image. So that is why convex mirrors are used as rear view mirrors. So that entire image at any point of object position, the image is erect and diminished, so that the whole image can be covered in a mirror, right? So you can see the entire picture of an object. So that is why it is used as a rear view mirrors in the vehicles. And there is one more question. Write the relationship between the focal length and radius of curvature of a convex mirror. Very simple. If you consider R as a radius of curvature and F as a focal length, so radius of curvature R is equal to 2F. So this is quite a simple formula that you had learned, right? So this is all about 8th question. So with this we are done with 2 marker questions. Now we will go for 3 marker questions, that is main 4. So you have 9th, 11th and 10th. Okay, 3 questions, 9, 10 and 11. So let us quickly go for the 9th question, which is from sources of energy. Very simple question. Explain the method of production of biogas in biogas plant and write any 2 characteristics of biogas. Okay, so let me mention the points on a board now. You can follow these simple points for this 9th question, that is production of biogas in biogas plant. See, you must have observed a diagram, right? See, a dome-like structure constructed with bricks, right? So a dome-like structure. So you have something called digesters. Okay, so just very roughly I am drawing a diagram. It's a dome-like structure. So here you have something called digester, the main compartment where the decomposition of waste materials takes place, right? From this end we add the mixture of cow dung and water, which is called as a slurry, right? So look at the points that I have written. The plant has a dome-like structure built with bricks. Later, a slurry of cow dung and water, that means it is a mixture of cow dung and water, is added to digester. So this is the main compartment, digester. From here we will add, it will go here. So these cow dung will contain complex compounds, organic compounds. So these organic compounds are broken down into simple gases like carbon dioxide, methane, hydrogen and hydrogen sulfide by anaerobic microorganisms. In the absence of air or oxygen, the microorganisms will convert the complex organic compounds into the simple gases. So this methane gas is the major constituent here. This is used as a biogas. This mixture in fact is used as a biogas. Okay, so the main ingredient, the main constituent is methane here. Clear? So these are the points you have to write carefully. So this is how the biogas is formed. And they have also asked you the characteristics of biogas, right? So there are so many characteristics. Among them 3 characteristics I have listed here. One is the biogas produces very less smoke, no residue, okay, no left out things, and the slurry left. So after the production of biogas, so whatever the waste that is generated, this will contain, this waste, the spent slurry we say, that is the used slurry, is rich with nitrogen and phosphorus. So it can be used as a manure, that means as a fertilizer for different crops in agriculture. Okay, so slurry left is used as a manure. So these are the 3 points, you can write it as a characteristics. Okay, so in a very simple sentences I have written the points. So 3 points and 3 characteristics, or just write any 2 characteristics, that is also fine. Clear? And coming to OR option. So in the same 9th question you have this OR question. How power is generated? Power in the sense electricity. How power is generated from nuclear energy? Explain. Write any 2 hazards of nuclear power generation. So how is electricity is produced in case of nuclear plants? So in nuclear plants we take heavy elements like uranium, plutonium. Okay, so these are the elements that is taken in a plant, nuclear plant, which is a huge constructed materials. Okay, so nuclear fission chain reaction, the heavy atoms when they are hit with lightweight particles. See here, the heavy atoms when bombarded in the sense hitting. So when you hit these heavy atoms with lightweight neutrons, certain particles gets liberated, and this is called as, nuclear fission reaction. And this happens continuously. Okay, so when the heavy atoms are hit by lightweight particles, so this gets splitted up into smaller particles. This is called as nuclear fission reaction. And when this fission reaction happens, large amount of energy is released, that is heat is released. Energy in the sense heat. Okay, see, during this process large amount of energy is released, and this energy is used to create steam. Okay, and further it helps in the generation of electricity. Okay, so this is how you can mention the answer in a simple sentences. And they also asked you hazards of nuclear power generation, no? That means why the nuclear power generation is dangerous. I mean, what are the disadvantages? Okay, hazards in the sense disadvantages of this process. See, one thing is storage and disposal of used fuel is difficult, and the major thing is leakage of radiations. In case of any accidents, if these radiations that are coming out from the heavy atoms, you know, if you observe the radiations coming out, it's very much harmful for the human beings. Okay, so all these radiations are actually cancer causing agents, right? So these are the two disadvantages of nuclear energy, right? So that is all about the 9th question. And coming to 10th question, it is a ray diagram, and this is also important, guys. All the ray diagrams you have to practice thoroughly, because any one ray diagram can be asked for 3 marks. Okay, so they'll ask you to draw a ray diagram. So you have, you know, mirrors, right? Concave mirror and convex mirror. In case of concave mirror, you have learnt 6 ray diagrams, and in case of convex mirror, you have learnt 2 ray diagrams. Same case with lenses also. See, convex lens, I already told you, concave mirror and convex lens are similar. Okay, so here you have 6 ray diagrams, and concave lens has got 2 ray diagrams. Okay, so altogether 6 plus 2, 8 ray diagrams under mirrors and 8 ray diagrams under lenses. So these ray diagrams are very, very important to practice, and if you want to know how to draw these ray diagrams, you can watch the playlist of the chapter Light, Reflection and Refraction, where I have explained how to draw the ray diagrams in a very detailed way. Okay, so the playlist link is provided in the description. Don't forget to check it out. So now I'll just draw a ray diagram what is asked in a question. They said, draw the ray diagram of image formation when the object is kept at C of the concave mirror. With the help of ray diagram, mention position and the nature of image formed. Okay, see, they are asking you to draw a ray diagram for concave mirror. So here let me take this as a concave mirror, and here the center point is called as a pole, and this is a principal axis, and this, let me call it as C. Okay, so they said if the object is kept at C, what will happen, right? And let this be principal focus, that is focal point. So if a incident ray is parallel to the principal axis, then the reflected ray will pass through a principal focus. So this is the direction of reflected ray. And I'll take one more incident ray that is passing through principal focus. So what would happen? The reflected ray will run parallel to the principal focus. So here you will get the image. And look at the image. So this is our image, right? This is our object. So where are you getting the image? Image position. So mention your answer like this, image position. So where is the image position? Image position is at C itself. Okay, and nature of the image. So nature, real and inverted image, right? And image is of same size of an object. So whenever object is kept at C, the image is formed at C only, but it's a real and inverted, and the size of the image is same as that of the size of object. Okay, so this is the ray diagram that was asked. So now let us go for question number 11. It is from Human Eye and Colorful World chapter. Very simple question. Stars appear to be twinkling. Why? It's because of atmospheric refraction, isn't it? Stars appear to be twinkling. Why? Explain. You have to explain in some points. And what are the reasons for the appearance of the sun in red color during sunrise? During sunrise and sunset, the sun appears to be in red color. So what is the reason they are asking? So you have to explain that in different points. So the points in a simple form I'll mention on a board. You can just look and observe. So guys, here I have written the points in a very simple way. You can note it down or you can take a screenshot. See, I'll read out all the points and explain to you. Stars twinkle. It's mainly due to atmospheric refraction. So this word atmospheric refraction is a key word here. See, atmosphere contains many particles, like there are so many gases, dust particles are there and many different chemical compounds, right? So whenever light is passed through these particles, refraction of light takes place because the speed of light differs when they pass in a different particles, right? So continuous refraction keeps on happens, okay, when a light from a star has to reach our eye. So what happens is the light from the stars will be passed through atmosphere whose refractive index keeps on changing because there are so many particles, different medium has different extent of bending a light. So continuously refraction keeps happening. So there will be changes in the intensity of light, that is amount of light that is coming from stars reaching our eye, causing a twinkling effect. Okay, so these are the 3 points that you can write. And coming to the next question, why do the sky appear red, during sunrise and sunset? The reason. So here also very simple, near the horizon most of the blue light and shorter wavelength. So with Gayar, among the 7 colored radiation, we all know that these violet, indigo, blue, these radiations have very less wavelength, right? So they have less wavelength, and whereas the red radiation has got the highest wavelength. So what happens is near the horizon, most of the blue light and shorter wavelengths will be scattered by the particles. So atmosphere has lots of gaseous particles, lots of gases, dust, etc. So all these particles, what do they do is they'll scatter the radiations of less wavelength. So what happens is the light that reaches our eye is longer wavelength. So the light which has got a longer wavelength will be reached to our eye. Blue color and all other shorter wavelength got scattered by the particles. So now only left out radiation from white light is the longer wavelength, like orange radiation, red radiation. So these wavelength will reach our eye. That is why the sky appears red during sunset and sunrise. Okay, so that is all about the answer. And now that's all about the 3 marker questions. Now coming to 4 marker question. You have 2 4 marker question in the physics part. That is question number 12 and question number 13. So question number 12 and question number 12 has again 2 questions like A and B. So both are problems from the chapter electricity. So actually these problems are very simple. Definitely you can expect problems from electricity as well as light chapter also. In the model question paper, problem from a light chapter is missed, but definitely you can expect it for board examination. Do practice problems on light chapter. So they are all very simple formulas, right? So you have to work only on 2 formulas. One is a mirror formula, the other one is a lens formula. Okay. And coming to electricity chapters, yes, you have to work different models. You should work problems on calculating electric current, potential difference, resistivity problems, okay, cost problems, power related problems, problems relating to Joule's law of electric current, problems relating to resistors in series and parallel. So you have all these models, so you have to be thorough with all the problems. So here let me deal with these two questions that are there in model paper. So coming to 12th question, A question. Okay, so for A you have 2 marks and for B you have 2 marks. So look at the question on a board. Two resistors of resistance 5 ohm and 20 ohms are connected in parallel. Okay, so there are two resistors. So one resistor was having 5 ohms resistance, the other resistor was having 20 ohm resistors, and both of them are connected to a battery. Okay, so with voltage 12 volt. So this is a 12 volt battery. Calculate the total resistance in the electric circuit and the total current flowing in this circuit. Okay, fine. Sorry, they are connected in parallel, right? So they are not connected in series. So they are connected in parallel, right? So this is 5 ohm, right? And the other one is a 20 ohm. Both are connected to 12 volt battery. Fine. First you calculate the total resistance. So you know, whenever the resistors are connected in a parallel way, how do you calculate the total resistance? It is 1 by R is equal to 1 by R1 plus 1 by R2. Okay, so let me consider this as R1 and this as R2. So what is R1? 1 by 5 plus 1 by 20. So what is the LCM that you can take? 20 is the LCM. So 5 4s are 20, right? So 4 and here 1. So 5 by 20. So R is equal to 1 by R is equal to 5 by 20. So R is equal to 20 by 5, right? So 5 ones are 5 4s are. So R is equal to 4 ohms. So this is the total resistance. And they also asked you to calculate the total current flowing in the circuit, right? So what is the Ohm's law formula here? Ohm's law, that is V is equal to IR. So voltage is given. How much is the voltage? 12 volt is equal to I into what is the total resistance? 4. So I is equal to 12 by 4. So 4 ones are 4 threes are. So I is equal to 3 amperes. Don't forget to put the unit. Okay, so for resistance the unit is ohms, for electric current the unit is ampere. So total resistance is 4 ohms and total current is 3 amperes, right? So this is how you have to calculate the problem. This is really very simple problem. Okay, but for the boards, do prepare. I mean, you have to be prepared for n number of problems from the electricity chapter. And coming to question number B, this is also a problem only. 20 joules of heat is produced. So the heat produced, heat is always indicated as H here. So H value is given, that is 20 joules. And heat is produced in 2 seconds. So time is given here. Time is always indicated as small t in the chapter electricity, right? And the units are seconds here. So time is given, that is 2 seconds. And resistance is given, that is R is given 8 ohms. Find the potential difference across the resistor. Potential difference, that is V they are asking. So which formula do you use here? So very simple, you have Joule's law of heating, right? So H is equal to VIT. Voltage into current into time. Okay, so this formula you can use. And see here, V is what they are asking you to calculate. So this is question mark. H is given 20 joules. And I is not given actually. Time is given, it is 2 seconds. But how do you calculate I? You have Ohm's law formula, right? That is V is equal to IR is there, right? So I is equal to V by R. So I'll substitute I is equal to V by R here. In the place of I'll write V by R. So what do I get? H is equal to V into I. In the place of I, what we can write? V by R into T. So this becomes H is equal to V into V is V square T by R. Okay, so just rearrange the formula. This, if it goes this side, you will get H into R, okay, divided by T will give you V square. You want to find out V. All these are given. So just substitute. H is what? H is 200 joules into R. R is what? 8 divided by T. T is what? 2. So 2 ones are 2 fours are. You will get here 800, right? 4 2s are 8. So 800. So here V square is equal to 800. So V is equal to square root of 800 you have to do. So square root of 800 is approximately 28.2 volts. Okay, so this much is the answer that you will get. Right, so that is all about the problem B. Right, and now if we move on to question number 13, this is again a 4-marker question from the chapter Magnetic Effect of Electric Current. Definitely a conceptual question on Faraday's experiment. Okay, so you all must have had an idea about electromagnetic induction, which was discovered by understanding Faraday's experiment, right? So here if you look at 13th question A, coil 1 is connected to a battery and plug key, and coil 2 with galvanometer are kept close to each other as shown in a diagram. Okay, so if we have to draw a diagram roughly, so you know this is coil 1, this is coil 2. So coil 1 has got a battery and a key, right? And coil 2 has got a galvanometer. So you all know, if you on and off this key, magnetic field changes, okay? And changing magnetic field induces current. So whenever current is induced in coil 2, you will observe a deflection in galvanometer, right? So this is the experiment that we studied. So what they are asking is, write your observation in the galvanometer when plug key is closed. Okay, when plug key is closed and when plug key is open. In both cases, okay, in both cases you will observe. So what you will write your answer? Deflection. Deflection in galvanometer. Galvanometer is observed. Is observed. Is observed. Okay, so this is what you have to write. Suppose when plug key is closed, if you find a deflection in the right side, then when plug key is open, you will find the deflection on left side. Okay, so the direction of deflection will be opposite, but definitely there is a deflection in the galvanometer. And they are also asking, give reason for your observation. So what is the reason? So when plug key is open and closed, change in the magnetic field takes place. Change in magnetic field takes place. Okay, and changing magnetic field induces current. Induces current in coil 2. Okay, so this is your answer, guys. So very much conceptual. For this you have 2 marks. So what happens when closed and open? What happens? Deflection in galvanometer is observed in opposite direction. For that maybe 1 mark. Okay, and why this deflection is observed? It because magnetic field changes here in the region around coil 1 and 2. So change in the magnetic field induces electric current in coil 2. That's why you find the deflection in galvanometer. Okay, so very simple. Next, B question. So B question, very simple. Write the functions of following: earthing wire and electric fuse. So earthing wire actually provides low resistance conducting path. conducting path. Okay, so whenever an electric current is leaked on a metallic body, what happens? All the leaked current will pass through this earth wire, which has got a very low resistance, so that quickly all the electric current is getting passed and it is delivered to a earth, right? So the earthing wire is connected somewhere to the ground, so that electric current gets disposed safely. Okay, so it prevents us from getting electric shocks, right? So that is the use of earthing wire. And then they are asking, what is the use of electric fuse? It prevents damage. It prevents damage to circuit and electric appliances due to overloading. Okay, so in case of overloading, there are many chances of spoiling or damaging electric appliances and circuit. So to prevent that, the fuse wires can be used. Okay, so these are all very simple questions, right? You can easily write their definitions: overloading, short circuiting, fuse, earth wire, all these are very, very important to learn. So that is all about the physics section, guys. With this, we are done with the physics section. In the next video, I will come up with chemistry and biology questions, because the video has become more lengthy. So the next chemistry and bio part I'll cover in the next video. Okay, so thank you so much. Do share all these answers with your friends also. Let everybody get benefit out of this. Thank you so much. Keep learning. Meet you all in the next video.